Here in this video, we're going to learn how to take the derivative of ln functions. Now the basic ln rule is d du of ln of u is equal to u prime over u. So we're going to take the derivative of what's in the parentheses and put it in the numerator, and we're going to put whatever is in the parentheses in the denominator. And the basic example is d dx of ln of x. So x itself is the argument of the ln function. We put that in the denominator, and then the derivative of x is 1. Now, some of your basic properties of ln I've written down too, and I'm going to show an example of each. So here, if we have the ln of m times n, we can rewrite it as ln of m plus the ln of n. And on the right, I have the ln of 4x plus 3 times 2x plus 1. And that can be rewritten as ln of 4x plus 3 plus the ln of 2x plus 1. The second property is the ln of m divided by n is equal to the ln of m minus the ln of n. So in this case, we'd have ln of 4x plus 3 divided by 2x plus 1 is equal to ln of 4x plus 3 minus ln of 2x plus 1. And the final rule is, if we have ln of m raised to the n, we can bring the exponent out front. So it's equal to n times ln of m. And in this case, if we had ln of x cubed, we could rewrite that as 3 ln of x. Now all these properties will make taking derivatives of ln functions much easier, so that's why I showed them. In my first example, I have f of x is equal to ln of 5x. So remember the rule, we have f prime of x is equal to d dx of 5x divided by 5x. And the derivative of 5x is 5. So we get left with 5 over 5x, which could be simplified also to 1 over x. The 5's cancel. In this next example, I have f of x is equal to ln of x squared plus 4x. And when I take the derivative of an ln, the first thing I do is draw myself a fraction bar and write whatever is in the parentheses in the denominator. So I can write x squared plus 4x. And now I take the derivative of that and put it in the numerator. So I have 2x plus 4. And that's the derivative of that function. In this next one, first thing I'm going to do is rewrite it in terms just like we used to and get rid of the roots just like we did in previous videos. So I'm going to say f of x is equal to ln of x to the 1/3. And then if you notice, this was one of the properties that we had, so I'm going to use that property and rewrite it one more time before I take the derivative. So f of x is equal to 1/3 ln of x. And f prime of x then is equal to 1/3 times the derivative of ln of x, which, so we draw our fraction bar, we put the x in the denominator, and then the derivative of x is 1. So we end up with is 1 over 3x. In the next example, again, we can use one of the properties from above to make this much easier. If you don't use the properties, you end up having to use the quotient rule to take the derivative of what's inside the ln. So here, I'm going to rewrite it so that I don't have to do it the long way. And I'm going to say ln of 5x minus ln of 7x plus 3. Now I'm going to take the derivative. So f prime of x is equal to and I'm going to put my fraction bar, 5x in the bottom, and the derivative of 5x is 5. And remember, we don't take derivatives through plus and minus signs, so we're just going to put our minus sign in there. And another fraction bar, 7x plus 3 in the bottom, and then the derivative of 7x plus 3 is 7, and that will go in the numerator. So we can simplify this and say that f prime of x is equal to 1 over x minus 7 over 7x plus 3. Here in my final example, I have something that we have to use the product rule for, and we're also going to need to use the exponential rule and the ln rule. So I'm going to write down all the notation as we go to make sure that you're following along. So f prime of x is equal to f of x, e to the 3x, times the derivative of ln of 4x plus the derivative of e to the 3x times ln of 4x. And now we take our derivatives. So we have f prime of x is equal to e to the 3x times, now we have ln of 4x, so I put my bar and put my 4x on the bottom, and the derivative of 4x is equal to 4, plus the derivative of e to the 3x is the rewrite times the derivative of the exponent. So we have 3e to the 3x times ln of 4x. And there's a little simplification I can do on this one. So f prime of x is equal to e to the 3x divided by x plus 3e to the 3x ln of 4x. And that's how we would use the product rule along with the exponential rule and the ln rule at the same time.